Good morning, children. Welcome to all of you in the physics class. Today, I will explain all of you to the new topic, that is sound, which is given at the top. What is sound? Sound is a form of energy. Which type of energy? Sound is a mechanical energy that creates the vibrations in our ear, so we can able to hear anything or listen anything. Sound is perceived by us only when the number of vibration per second is from 20 to 20,000. The limit is called limit of audibility, which is given here. And the definition again, I would like to explain. Sound is a form of energy that is given this. Now, moving forward, the sound frequency below 20 vibrations per second is called subsonic or infrasonic, while the sound frequency above 20,000 vibrations per second is called ultrasonic. In the activity number 1, one simple pendulum is hanging here, and the vibrating tuning fork comes to the pendulum, and as a result the pendulum start vibration because the sound energy transmitted from fork to the pendulum. Okay. Now, in same manner, a filled water glass, when it is still, but when contact to the vibrating tuning fork, that is in U shape, touch to the glass of water, then water and glass start vibrating because the tuning fork vibration energy transmitted to the glass. So in this way we can say that without vibration of the media, sound cannot be produced. So for sound, it is very important that any media should be present. Without any media, sound cannot be travel. So we cannot hear anything. Now moving forward, we are discuss about now propagation of sound. Sound is produced when some material body is made to vibrate. This material of substance through which sound is transmitted is called medium. Medium for transmission can be solid, liquid or gas. For doing this, an electric bell is suspended inside a bell and connected to a vacuum pump as the electric circuit which are given here. Then what the consequences comes, which is important for you. The medium required for propagation of sound must have the following properties. First is medium must be elastic, medium must have the inertia, and the frictional resistances of the medium should be negligible. So we can say that sound travels through both solids and liquids at a greater speed than through the air. Okay. This is the values which are given of the speed of sounds in solids, that is aluminum, nickel, steel, iron, brass, glass. These are solids. And here the speed 6420 in aluminum, nickel 6040, steel 5960. You can see here in solid the speed of sound is very much larger than that of the liquid and gases. When we are talking about the liquids, suppose water, ethanol, methanol, it decreases. When we are talking about the gases, it very much decreases. Suppose that in sulfur dioxide the speed of sound is 213 meter per second. Okay. However, in the air its value is 332 meter per second. Now moving forward, one interesting observation which are given here, that is the medium does not leave its place during transmission of sound. This property is seen here. How? For this, anybody take a glass rod that is pointed in one side and second end is cylindrical and circular, that is open end, and if we take the two stones and starts vibration or sound through it inside the pipe, and the glass tube filled with the smoke, then after creating the sound, the other end candle is burning, then sound creates and goes through the glass tube and start vibrating the spark, or you can say the lightning area of the candle vibrating. What comes here? Smoke particles does not goes outside. However, the sound waves passes through the glass tube and go outside and start vibrating to the light of the candle. So we can say that sound can a wave, it does not move along with the particles. So particles of the medium remains the same position. This can be understood by this experiment. Now moving forward, sound travels in a medium in the form of waves. How can we understand it? Suppose wave motion, because very interesting thing which is given here, it is form of disturbance which travels through the medium due to the periodic motion of the particle of the medium about their mean position. The disturbance being handed over from one particle to the next. So we can say that the wave which required material media for their transmission are called elastic waves or mechanical waves. For example, vibration in a rope, a string, vibration on the surface of water, all are the example of transmission waves, mechanical waves. A mechanical wave is produced when quite large number of medium particles execute vibrations simultaneously. This wave is propagated by mechanical vibration of the medium particles. The disturbance or vibration caused in the particle of medium is transferred from first particle to the second, from second to the third, and so on. This is wave motion, energy transferred from the source to the other parts of the medium by the vibration of medium particle. But there is no displacement of the medium as a whole. This is very important. As I have already explained, the wave generated at the surface of water are transverse waves. This picture shows here when any stone is put or thrown on the still water and one cork piece is placed at the surface of the water, then the stone creates the vibration at the surface, and as a result the cork start vibration up and down, but still its location remains the same, but wave can move further. It can be seen in this picture. First line is stone, second the vibration start, third goes onwards, and further the location of the cork is same, but wave can be transmitted from one end to the another. This is the experimental picture that shows the waves travels, not the media. Therefore, the particles of water make their oscillation perpendicular to the direction of the waves. Thus, the process in which the disturbance moves forward is called wave motion. Now, some characteristics of wave motion which are given here. First is, it is the disturbance produced in the medium by the periodic motion. Second, due to the wave motion, this disturbance moves forward from particle to particle in the medium. Third, in a wave motion, the particles of medium vibrate to and fro about their mean position. Similarly, in a wave motion, the kinetic energy of the oscillation of the particles transferred from one particle to the other, that is energy transferred from one place to the other. In the fifth point, the velocity of the wave is different from the velocity with which the particles of the medium are vibrating about their mean position. The wave travels with a uniform velocity, whereas the velocity of the particles is different at different positions. It is maximum at the mean position and zero at the extreme position of the particles. Now, there are two types of waves, transverse waves and longitudinal waves. Transverse waves, the waves in which the particles of the medium vibrate up and down about their mean position at the right angle to the direction of propagation of the waves. For example, the wave at the water surface and the wave in a string, etc. I have already explained, and it can be understood by the picture here. A, B, C, D, E, F, G are the points created on the string that is tied from one end and start vibrating from the other end. Then you can see that the position of A, B, C, D, E, F, G, H are not changed. Only wave transmitting is seen here. Okay, so we can say that this is a transverse wave. Another picture is shown here because it creates on the surface of water, then it creates trough and crest. The mountain type part is called crest and valley type part is called trough. That is given here. The two consecutive crest distance or two consecutive trough distance is called wavelength. That is denoted by lambda. It's have the unit meter. So for today, it is about the types of waves, sounds. So now rest part I will explain in the next video. Thank you all of you for watching. Thanks a lot.